In the summer of 1978, the newest skyscraper on the Manhattan skyline had a 1 in 16 chance of collapsing in any given year. 59 floors, 915 feet, thousands of people working inside, all of it standing on 4 stilts and 1 electric machine. And the only people who knew were a handful of engineers, meeting in secret, watching the Atlantic hurricane forecast. This is the story of how they fixed a falling skyscraper without telling the city underneath it. Margin of failure. Case file L01. The Citicorp Center. Every disaster in this series comes down to a margin, the gap between the load a structure will face and the load it can take. But this case is different. This is the one where the flaw was found before the building fell. Ballet. Start at the corner of 53rd Street and Lexington Avenue. In the early 1970s, Citicorp wants a full city block for its new headquarters. But one corner is not for sale. St. Peter's Lutheran Church has stood there for over a century, and it will only sell its land on one condition. A brand new church must stand free on that same corner with the skyscraper built around it, not on top of it. So architect Hugh Stubbins and structural engineer William LeMessurier do something no one had tried at this scale. They lift the entire tower more than 100 feet into the air. 4 columns, each 114 feet tall. And here is the trick. They are not at the corners. They stand at the middle of each side, so the tower's corner can hang out over the church. To make that work, LeMessurier ran giant diagonal braces up the tower, stacked in 8-story chevrons, like arrows pointing at the sky. The chevrons collect the building's weight and its wind loads, and funnel everything down into those 4 columns. It was brilliant. It was also unusually light for its size. And light buildings have a problem: wind. The tower swayed enough in the wind that LeMessurier added something no American skyscraper had used before: a tune mass damper. Near the top of the building, a 400-ton block of concrete floats on a thin film of oil. When the tower sways, the block lags behind and pushes back, canceling out roughly 40% of the motion. Remember that machine. In a few minutes, it will be one of the only things keeping this building standing. Spring 1978. The tower has been open for about a year. A Princeton engineering undergraduate named Diane Hartley is writing her senior thesis on the building, and LeMessurier's firm sends her the plans and calculations. But her numbers will not behave. Building codes at the time required checking wind hitting each face of a building straight on. Hartley checked something the code did not ask for: quartering winds. Wind striking the corner, loading 2 faces at once. Her results said those diagonal winds stressed some of the braces far more than the design assumed. An engineer at the firm assured her the building was safe. She handed in her thesis and moved on. The question reached William LeMessurier, and that summer he ran the numbers himself. For a tower built of chevrons, a quartering wind raises the stress in half the braces by 40%. On its own, that is survivable. The welded joints in his design carried huge reserves. Then came the discovery that turned a footnote into a crisis. During construction, the builders had made a money-saving substitution, and his own firm had approved it. The braces were not welded. They were bolted. Perfectly legal. Standard practice. But the bolts had been sized for the winds the code asked about, face on. Under a quartering wind, the force on some of those bolted connections jumped by 160%. LeMessurier brought in wind tunnel experts and weather statisticians, and the answer came back colder every time. The weakest joint, up on the 30th floor, could be torn apart by a storm strong enough to hit New York, on average, once every 55 years. And even that assumed the tune mass damper kept working. But the damper runs on electric pumps, and big storms take out the power. With the damper dead, the number fell to 1 in 16. Every single year, the newest skyscraper in New York was quietly rolling a 16-sided die, and hurricane season had already begun. LeMessurier understood exactly what honesty would cost. Telling the truth meant announcing that his own masterpiece could fall. The lawsuits alone could end his license, his firm, his name. He admitted later that silence crossed his mind, and briefly, so did worse. Instead, he alerted the architect, the lawyers, the insurers, and then Citicorp itself, and said, in effect, my building is unsafe. Here is exactly why, and here is how I am going to fix it. The plan: weld thick steel plates over more than 200 bolted joints, turning every weak connection into something stronger than the original design. But the tower was full of tenants, so the welders came at night. In the evening, crews sealed off the work zones with plywood. Welders worked into the early morning, cleanup crews erased the evidence, and office workers arrived at 9, none the wiser. The Red Cross quietly drafted evacuation plans for the surrounding blocks. Weather services delivered hurricane forecasts 3 times a day. Strain gauge gauges watched the braces around the clock. Citicorp's public statement said only that the wind braces were being reinforced, and that there was no danger. And in a stroke of pure luck for the secret, New York's major newspapers had just gone on strike. The story simply never appeared. Then, in the first days of September, with the most critical joints still unfinished, Hurricane Ella formed off the American coast, and the forecast track bent toward New York. Emergency generators stood ready to keep the damper alive. The evacuation plans came off the shelf. The engineers watched a storm crawl up the map toward their half-repaired building. And then, Ella turned. She curved east out over the Atlantic and died at sea, never touching land. Weeks later, the last plate was welded shut. By LeMessurier's own math, the tower could now stand up to a 700-year storm. And here is the strangest part. Through all of it, the crisis meetings, the midnight welding, the evacuation plans sitting ready in a drawer, the tower never closed. Thousands of people rode its elevators every morning, worked their shifts under that slanted roof, went home, and came back the next day. No one was ever evacuated, because the storm never came. For everyone outside a small circle of insiders, the most dangerous office building in Manhattan was just an office building. Every case file ends here, the margin. So, where exactly did this one live? Not in the bolts. They met the building code. Not in the math. The firm's own numbers held the answer all along. The margin lived in a blind spot. The code only asked about wind hitting the building face on, and for one strange tower standing on stilts, that was the wrong question. Safety margins do not fail loudly. They fail quietly, in the gap between what the rules require and what the structure actually faces. The Citicorp Center survived because one student asked an impolite question, and one engineer chose to take it seriously. The margin of failure was rebuilt, joint by joint, before the load ever arrived. That is the whole game. The public learned none of this for 17 years. Then, in 1995, writer Joe Morgenstern overheard the story being told at a party, checked it, and published it in The New Yorker. Engineering schools now teach this case twice. Once as a warning about unchecked assumptions, and once as a gold standard of professional ethics, because LeMessurier reported himself, and his reputation survived because of it. And Diane Hartley? She only learned decades later that her student thesis had set the entire rescue in motion. William LeMessurier died in 2007, remembered less for the mistake than for what he did about it. And the building still stands at Lexington and 53rd. 59 floors on 4 stilts, with its margin welded back in. Next case file, the most famous shipwreck on Earth, but not the story you know. The iceberg did not slice the Titanic open. Her hull was held together by 3 million rivets, and the ones that mattered were made of the wrong iron. Subscribe, so you don't miss the file. Case closed, for now.